Space, the final frontier. This is the Observer's Notebook, the official podcast of the Association of Lunar and Planetary Observers. Its mission to explore the solar system, to seek out new observations and data, to boldly go where no podcast has gone before. And now the host of the Observer's Notebook, Tim Robertson.
Hello and welcome to episode 207 of the Observer's Notebook, the official podcast of the Association of Lunar and Planetary Observers. I am Tim Robertson, the host of the podcast, and also the coordinator of the training program within the Association of Lunar and Planetary Observers. Thanks for downloading and listening. The ALPO collects and analyzes observations of various solar system bodies and associated phenomena, and publishes detailed reports concerning these bodies in its quarterly publication, the Journal of the Association of Lunar and Planetary Observers. This podcast depends upon donations from you, our listeners, to keep it going. If you enjoy what you hear in the podcast, please donate to it via Patreon. You can start off by giving as little as $1 a month. If you feel even more generous, for $5, you receive early access to the podcast before it goes public. For a monthly donation of $10, you receive a copy of the Novice Observer's Handbook. And for $35 a month, you receive producer credits on the podcast. You can find out more by going to www.patreon, that's patreon.com/Observer's Notebook. And if you'd like to join the ALPO, membership begins at only $22 a year. For more information, find us at www.alpo-astronomy.org. And you can also find us on Facebook. Just search for ALPO Astronomy. And yes, this podcast also has a Facebook page as well. Just search for Observer's Notebook. And if you enjoy what you hear in the podcast, please subscribe. That way you'll never miss another episode. And now, episode 207. And we're going to talk about finding comets and asteroids and all sorts of things in deep space. Hope you enjoy. All right, I'd like to welcome everybody back to this edition of the Observer's Notebook podcast. And today we have a very special guest on the podcast, Sam Deen. Sam came to my vision, I guess, when I was doing some research for our big comets of 2025 when I talked to Carl Hergenrother. And I was doing some research on some comets coming up. And I'm looking at the bulletins for the latest comet discoveries, and one name kept popping up, and that was your name, Sam.
Well, hi.
Hi.
I'm an amateur astronomer who does some research with a bunch of big telescopes all over the world, Chile, Hawaii, and such. And I like to study comets and asteroids and other unusual solar system objects. And yeah, I've been doing quite a bit of vigilante observing around the solar system over the past few years.
Yeah. Now, what got me though is it said you live in Simi Valley, which is where I live, and I thought I knew all the astronomers in this little town, but apparently I don't. So you basically search for lost and unknown bodies in the solar system, asteroids, comets, and such, don't you?
Yeah.
So what's your background?
Well, it's a bit hodgepodge. It initially started off with me finding an ad in the astronomy magazine back in, 2011 or so, where they had some advertisement for Zooniverse, those citizen science project guys. They had a listing for the Planet Hunters project where people were looking through Kepler data for exoplanets and such. And me being, I think 9 at the time.
What? You were 9?
Oh yeah. I was a nerd.
Okay. Nothing's wrong with that.
I was thinking, whoa, people can just, without any qualifications, go just discover exoplanets and find crazy new stuff that we only just discovered existed a little while ago. That blew my mind. So I went looking around, and I eventually found the Galaxy Zoo project, and happened to notice that in the project, amidst so the project is looking at different galaxies and studying like what kind of galaxy they are. Are they a spiral galaxy? Are they a random irregular galaxy and such? But I kept noticing there were these weird dots of red, green, and blue that kept passing through all of the galaxies, and apparently they were asteroids, which nobody in the project was researching. And at the time, actually, very few people had actually gone through that data and looked at the asteroids. And it really, it was crazy to me that there was these asteroids that some random schmuck who had not seen any of this sort of stuff and had any qualifications, remember 9 years old, um, was looking at and was like one of the first people to ever spot it. So that really,
That is
put a spark in my mind.
that is mind-boggling. Wow.
Yeah, yeah.
9 years old.
And, well, it's not a me thing. It's really on those great guys over at Zooniverse for taking very specialized data that took tons of people with crazy qualifications, huge amounts of effort to find and make accessible to the degree that even someone like me could find that. I mean, everyone has to start somewhere, and if there's nowhere accessible to start, you can't really start too well. So they really deserve the credit here. And uh, what happened in the end was I kept looking and trying to find more about those, and my interest in studying what was happening with those asteroids, what asteroids they were, what their orbits were, if there was anything interesting, eventually led me to proactively going after specific unusual objects. I found a few comets in the data,
Mm-hmm.
and it just sort of ballooned from there to the point that now there's new comets being discovered, and I'm like one of the first people to follow them up.
Wow. Now, did you have a mentor in any of this, or did you just happen upon this thing yourself? And I find this interesting. This is cool. I want to see where it goes.
Well, a lot of it was very self-guided. I can't exactly say that I didn't have any mentors. It's just a lot of it was the very great planetary science community that's been
Mm-hmm.
harboring my stupid questions since 2011. I mean, oh, there was the Galaxy Zoo forum, which was quite, despite the name, they also quite catered to my sort of shenanigans. There was this other guy named VJOM, VJOM,
Mm-hmm.
just big capital acronym, who was a Spanish, a Mexican Spanish speaking astronomer who sort of started doing the same sort of going through archival data and trying to find images of it that I had been doing before I was doing that, and he also was contributing to the project. And so he gave a fair bit of early guidance about where the places are, who to tell it to. I mean,
Okay.
not much point looking at asteroids if you don't know what the Minor Planet Center is.
Right. That's true. That's very true. Yeah. Wow. Now, what was it? The first aha moment when you saw those, you said the red and green streaks going across the field that no one was paying attention to, when you realized what it was and you contacted somebody about it.
Well, I think probably the big thing that I was very excited about, um, as a young kid, I definitely done a bit of browsing around Wikipedia and learning about all sorts of random solar system stuff.
Mm-hmm.
Um, and I always thought Sedna was really cool. You know, Sedna, the big distant one on that crazy far out orbit that
Oh, yeah, yeah, yeah.
shouldn't make sense according to like old solar system models at the time when it was found. Uh, and so I was thinking to myself, you know what? I wonder if Sedna's in this data. And so I did a bunch of really tedious searching. I found a table of all the positions it was in the sky the entire time the Sloan Digital Sky Survey, the data source that was used,
Mm-hmm.
the entire time they'd run. And I just put every single date that had a position into it into the locations, and then checked if the date was the same. And I really shouldn't have, but I did find an image of Sedna, and I was just thinking to myself, isn't it crazy that nobody has ever seen this image before, and maybe 100 people have ever seen Sedna before, and you can just look at it in this image and it's right there. And I was thinking, it, I should really
Tell
I should do
somebody.
something with this.
Yeah.
I mean,
Yeah.
if so few people have seen it, surely another person spotting it's got to be some contribution to science.
Agreed.
So
Yeah.
I figured out a way to report that. I really bothered the Minor Planet Center pretty early on with my I think I was then around 11-year-old submissions.
Oh, my goodness. But they knew you were serious right off the bat.
Oh yeah, yeah. They really there was a lot of guidance from the folks at the Minor Planet Center about, oh, here's the format, here's a bunch of documentation about what to do correctly. I
Hmm.
ended up talking to a few other people who were reporting stuff at the time. Um, it was a little difficult. The whole field of looking for things in archival data was a little bit of a dark art at the time.
Hmm.
Like people would do it and you'd have to meet them in a dark alley where they'd side eye you and say, "Oh yeah, I'd done that once or twice." And
Wow. That's fast. That's fascinating. So, you're currently, I think you said you're in Michigan now.
yeah, I'm currently in Michigan.
Okay. Are you
They
going to
just come back to
school?
see me.
Okay.
Hmm?
Are you going to school or anything? Are you?
Oh, no, I'm not currently in school. I did do 1 year at Northern Arizona University
Okay.
back in 2019, and then COVID hit, and that
Hmm.
kind of interrupted things a fair bit. And then it sort of got in the way of me doing current research stuff. I feel like university's in my future at some point, but I've been very much working as a man of trade more than anything else for
Hmm.
the moment.
Okay. So you're basically doing your own projects and reporting what you see.
Yeah, yeah, I'm self-guided, and I honestly kind of consider it a bit of a boon because to a point when you're working under specific um rules and goals as someone who's if I were to do this professionally, for example, you don't really have the freedom to look at something that you find interesting and go, what's with this? And look into that for a while. I mean, with a
Yeah.
lot of these asteroids, you come upon the fact that people had been they'd taken images of these things, images that really help improve the orbit or tell if an asteroid's going to hit us in 100 years or if a comet is going to pass really close to the sun or just kind of close. People had taken those images, but they weren't looking for comets or asteroids or something of that sort. They were
Hmm.
looking for, I don't know, supernovae or distant quasars. And because that was their thing, they never looked in that image to see if there were asteroids or bright, crazy comets in it. And so I feel like if you know what you're looking for, you're gonna find what you're looking for, and you're not gonna find things you aren't looking for. And
Yeah.
so, to a degree, just going where my mind takes me gives me a bit of I won't say better perspective, but a different perspective than some of the people whose sole job it is to take surveys and stuff along those lines.
Yeah. If you're working on a research grant, you'd have a certain project to do, and you'd have to stay within those boundaries.
Oh yeah,
You
definitely.
can take a left turn anytime you want.
Yeah, yeah.
And that's really nice that you're able to do that. And it's fascinating to me that you're using data that's really not yours, but it's collected from other people. And the images and everything you're using. Unless are you using telescopes now to do your own imaging or
Partially. They don't
okay.
do everything, but I did get a very wonderful arrangement, uh, an offer which I was perfectly capable of refusing, but no one in their mind wouldn't have. Uh, I got an offer from some fellow in Germany named Arndt Schnabel,
Hmm.
who was also working with a fellow from India called Divya Ruhela, and me, along with the two of them, operate the well, it's currently under observatory code XO9. It's the Deep Random Survey in Chile. We've got a 17-inch CDK telescope that we just have full operation of to observe whatever we want.
Really?
And it's really great being in Chile because you can look at all the crazy things in the southern hemisphere that none of the surveys are covering right now
Hmm.
before Vera Rubin Observatory comes online. So Atlas will discover something in the deep south that Mount Lemon and Pan-STARRS couldn't find, and I'll be right on top of it. I mean, I think right now, remember 2024 S1 Atlas, that sun grazer that came by and blew up and everyone hated it.
Yeah.
I think I'm actually the very second observations after the discovery ones from Atlas from X09, and it's entirely thanks to the generosity of Arndt there to decide to have this beautiful telescope and just go, it's yours. I want you to do great research on it. He's a very excellent guy. Bit of a shameless plug. I think we're at deeprandomsurvey.org.
Okay.
We have some coverage of research we do, totally just for fun and for advancing science and such.
So he finances the telescope.
Yeah, he owns the telescope. It's totally owned by him. Yeah, he wanted to have a cool telescope and wanted to have people do great research on it, and he's a wonderful guy.
That's fascinating. Huh. I don't know where to go with this. Yeah. Wow. So what are you doing right now? What projects are you working on right now?
Oh boy, well, there is a negative to being self-employed, as it were, that I'm simultaneously working on a dozen different things, because partially the notion of being doing stuff on your own means that you're also sometimes stuck with the projects that nobody else wanted to do because they're far too tedious.
Okay.
I was actually recently going through the Catalina Sky Survey archives, because the Catalina Sky Survey is like the biggest survey there is. You don't see too many comets named after them because they credit all of their individual observers who were observing at the time, who get sole credit for it. So you get a lot of comets named after each of the astronomers who are working there. There's Comets Foals, there's Comets Gibbs. He hasn't worked there in a fair bit, I think.
Mm-hmm.
There's Rankin, all the sorts of astronomers over there. And together that they have just this crazy conglomeration of survey telescopes that generate a whole ton of data and discover about half of all the big things, the other half being Pan-STARRS. Anyway, they've got a huge archive that's just publicly accessible that anyone can use over at the 1 second.
Mm-hmm.
Over at the Planetary Science Institute, they have a huge archive of every single image they've ever taken, and I've recently discovered that and discovered how to look through that to search for things, and I've been having a lot of fun going through all sorts of random things that they had in their data, but it was behind a star or really faint, and you couldn't have seen it unless you knew what you were looking for, and finding a bunch of crazy stuff that I feel like a kid in a candy shop whenever I get a new survey to look through, because
well, you are a kid.
yeah, I basically am.
Wow. So how many people are doing what you're doing?
Well, there's definitely a lot more people than there used to be.
Okay.
Back in 2015 or so, when I started really seriously doing this, there were a couple people. A few professionals did it as sort of a side thing, and of course there's the people who run their own surveys, the Catalina guys, using their own data as an archive. I don't think there were that many people going through other people's data on purpose looking for asteroids. I think nowadays there's a fair bit of them. There's quite a few. One of them is Peter Van Wylen. He goes through the data on the Atom asteroid. I don't remember what Atom stands for, I'm afraid.
Okay. Don't worry about it.
But it's this wonderful automated system that the Asteroid Institute has that has a whole bunch of different archives, and you just plug in an asteroid and it searches for images of it that you can then look at, and they give you a little thumbnail and you can look at them and verify them. That's made it a lot more accessible to people who want to have a look at these things. And folks like him are going through and looking for objects that are actually comets, but were misidentified as asteroids because usually they were too tiny or small or observed for such short a time that nobody looked at them and goes, "Huh, that's kind of weird. It's not supposed to be that bright."
Hmm.
And he looks through them and goes, "Wait, actually, that's a comet." And is working on a program to identify those better. There's a few others. Um, I'm not exactly sure how to pronounce it. It's either Adrian Coffinet or Adrian Coffinet.
Okay.
He also does a fair bit of work in the same realm. We all sort of work together and try to fill in the gaps of the asteroids that really should have been found but weren't for whatever reason, and together try and make sure that these asteroids and comets get properly seen.
Okay. What's the motivation to do this? Is it seeing something no one else has identified before, or to make discoveries, or what internally for you? What excites you to keep going with this?
Oh boy. Well, on the one hand, there is just the inherent joy of learning more about the solar system. There's a lot of stuff that we still don't know, despite the fact that we've been staring at it for a few thousand years.
Mm-hmm.
I mean, we have no idea exactly how many objects there are in the Oort cloud to begin with.
Mm-hmm.
Not even an order of magnitude estimate. I mean, we've got ideas, but we don't really have any way to tell. And that's partially because we've only been looking at comets for such a little time that we can't really see what the populations we're not spotting are. We haven't had time to. But another bigger one here is that being the guy who looks at the archival data, I get kind of an unusual privilege that a lot of the normal survey people don't. Because say you're operating one of those high cadence surveys that observes something and then reports it that night. If you do that, then you know that you found something, but you can't necessarily say that that same thing wouldn't have been found tomorrow by Pan-STARRS or Mount Lemmon or something of the sort.
Okay.
Not to take it away from them, but some asteroids and comets would have been found at some point. I mean, if we hadn't found Comet Tsuchinshan Atlas, we would have found it eventually in Swan or Soho. That would have appeared. But with looking at these things that are often years or sometimes decades in the past, you can look at these things, and as you're measuring that data, you can honestly, truthfully say, if I was not doing this, this never would have been found.
Wow.
This object would have been totally lost forever because it wasn't found. Nobody had found it. And so there's that unusual validation of the fact that what you're doing is truly actually, if I had not spotted this comet would have just passed right back into the Oort cloud unseen, and nobody would have ever recorded it.
That's very true. That's an interesting take on that. I like that. Huh. So if you could go back to the 9-year-old you and tell him what you know now, what would you tell yourself?
Oh boy. Well, I'd probably start shouting at him all the different crazy archives and weird strategies I found. I've learned a lot of strange strategies for asteroid hunting. It's almost second nature to me. I mean,
Okay.
I can get a weird feel when I'm looking for some old image. I was looking for Comet Swan. I think it was 2020 F8. It got fairly bright a little while back. It was supposed to get very bright, but didn't end up quite performing back in 2020. And I found what I thought were some images of it in 2019, way before its discovery. Basically, the only images taken before Swan noticed that there was something really bright in the sky. I mean, the way that Swan operates is they, I believe they use oxygen ions to survey the entire sky and look for really bright areas in that specific wavelength, which comets happen to be really bright in, but it's still not really designed for comets. So it'll only spot a comet once it's already gotten to magnitude 10 or something. So it's a bit of a last resort search. So these images back in 2019 were the last ones that had been taken before its discovery, and the only ones that had been taken and I was looking around and I couldn't find it. And then I spotted a smudge, and I just instantly knew that that was exactly the comet. I just get this feel, and
Really?
sometimes I look at something and I go, for all intents and purposes, this looks like it should be, and I can't quantify it, but this isn't it. And
Just an intuition thing with you, huh?
yeah, yeah.
Huh.
And I'd probably try and instill that sort of strange wonder and um the second natureness of hunting down these things to him, and also just show him how many crazy badass things have been found since then. I mean, I remember looking at interstellar objects like they were this theoretical thing that might happen some point, but probably not in my lifetime. And now we're staring at two of them.
Hmm. Wow. Okay. When you're doing your work, is most of your time just sat in front of a computer screen? Is that really what you're doing, or what else is involved?
A good bit of it is at the computer screen. There's a lot of different programs. I feel like when you're imagining someone at the computer, you might think that it's just some guy staring and poring over images, and it sometimes is, but it's a lot of going back and forth through 3 dozen different tabs and programs, cross-referencing stuff. I mean, to hunt down one asteroid or comet, I might need 3 dozen different tabs open of like the Minor Planet Center asteroid checker to make sure that I'm not looking at a smudge that's actually known. I might need the JPL horizons to get the positions. I'll have the Aladdin program from the CDS guys open with 7 different surveys to check against each other. I'll have the Canada Astronomical Data Center Solar System Object Image Search open, and I'll be zipping between all of those, looking back and forth, checking 17 different ways that the asteroid that I'm looking for or the comet that I'm hunting down should be there. Especially comets, because those are really hard to predict. It'll
Mhm.
say it's supposed to be magnitude
Oh
2,
yeah,
and
yeah,
you look
no,
and there's nothing there.
yeah. Don't get me started with that.
Oh boy.
Yeah, but so yeah, your process sounds very. I mean, it's you've developed this process for doing it the way you like to do it. Because you mentioned having all these tabs open on your computer and everything. So, how do you determine to go after an object? Is there something that the year of a discovery you say, well, I want to go back in time to see when was this first observed, or
I skip between a few different methods. I
okay?
don't necessarily have just one method, but a lot of the time it comes down to starting with a question that I have
Hmm.
or some curiosity that I want to satiate. For instance, there's the Century Risk Table, which has a very interesting asteroid on it right about now. Um, and that table contains asteroids that might hit Earth in the future. Now, these are not concerns right now. None of
Right,
the
right.
asteroids on the table are any point of concern. For all the viewers here, our biggest one has like a 1 in 10,000 chance of hitting, something along those lines.
Hmm.
And um, but the fact that they could hit Earth does nonetheless make them warranting some checking. And a lot of those asteroids have been on there for years because the problem is something that's 50 meters across, about 160 feet or so, is not going to be really observable from the ground very often. It might have appeared back in 2008 and we'll never see it again, until it hits us in theory, not actually probably, but in theory it could hit us without us having seen it again. And really the only thing to do is to look at the old archival data that nobody was looking at and
Hmm.
hunt down that thing. So sometimes I'll be going through that old archive trying to look at these asteroids that have huge sizes and a very small chance of hitting Earth, and try to make that chance zero, just for peace of mind, save some of the time away from Hubble and James Webb trying to hunt them down again. Some other times, recently I went through a bit of a project. There's a whole bunch of comets, surprisingly many actually, that have been found, and people observed them for a couple days, enough for them to get published as comets, and then for whatever reason, maybe really close to the sun, very far south in the middle of the galactic plane, people just never observed them again. They just stopped looking at them. They saw the comets for about 2 or 3 days, and then they were just moving on to something else.
Hmm.
And for those, I go, interesting. So what exactly happened here that made people stop doing it? And is there something that we can learn from that? And I'll try to look for more observations to get a better idea of the comet's path. I'll look for where the survey's covered, and try and get a better orbit. And if I can't get a better orbit, at least try to figure out what happened wrong, and potentially advise folks I know who are doing some of the surveys on how better to survey in cadence. And if I'm doing my own survey with our EXO 9 telescope, how better to make our survey run that doesn't miss these things in the future.
Yeah. So if someone wanted to start doing what you're doing, what advice would you give them?
Oh boy. I'd say the very first thing to do would probably be to find something that you want to learn more about. Pick some sort of part of the solar system that you think, I wonder what this is about. A few examples would be, well, the Lucy mission is going to visit the Trojan belts of Jupiter, and there's a whole lot of Trojan asteroids in there. In fact, I believe that there's considered to be, at certain size ranges, just about as many as the asteroid belt, but all in those thin little rings there, the little belts around Jupiter.
Okay.
And there's a lot of Trojans that have been found that do not have well-known orbits. And given that there's the same number but compressed in these little things, Lucy may be flying pretty close to some of them. So an idea I've had but not really pursued was to look around some of these brighter ones and see if I could get good orbits for these, so that Lucy knows to dodge if we need to say dodge at last minute.
That would be very helpful.
Oh yeah, yeah. But in all seriousness, we might end up, I mean, for all I know, you could end up accidentally doing a flyby right past one. There was actually the Dawn probe, which visited Ceres.
Mm-hmm.
While it was there, we now know in retrospect a fairly big asteroid, a kilometer or two across, passed right over Ceres, to the point that it was difficult to model its orbit back before and after. The Minor Planet Center had 2 different asteroids because its orbit had been so changed by passing by Ceres that they couldn't link the 2 together automatically. And nobody had noticed that this asteroid passed by. Dawn had no clue. And if we'd found that and gone, there it is, it's right there, and someone had pointed that out, then maybe we could have gotten a bonus free asteroid for the road while looking at Ceres.
Huh. Wow. So future plans. I mean, how, if you mind me asking, how old are you right now?
Oh, I'm sorry, I'm at the age where I have to check.
I'm at the age
I believe
I
I'm
remember.
23 right now.
23.
23.
Okay, yeah, I wasn't doing what you're doing when I was 23. I wish I was, man. That sounds amazing. So, looking at the future, you said college, maybe university might be in the future. What are you looking at, like 5-10 years down the road, if you are?
Well, for the moment, I'm trying to get as good a resume as I can under my belt. It would be very nice to come in and come up to a survey, and the survey is going, "Hey, why should we hire you in particular?" And then I show off all the dozens of asteroids that I found, and all the dozens of comets that I got good orbits for, and go, "Hey, I've actually looked at your survey data probably more than some of the people working there."
There you go.
And it would be nice also, in a more altruistic sense, for something crazy to come by, like Oumuamua again, and be able to march that back all the way. And I feel like those would make some very good career starters.
Definitely. Well, from what I've seen of your name on the Minor Planet circulars and things, you have a decent resume started with discoveries too. So.
Oh boy, yeah. and I'm actually starting to break into papers too. I've got a few papers written, a few more on the way.
Fantastic.
It's very wonderful that these days, I'm told you couldn't have done this very far in the past. As an amateur with no university affiliation, being able to just write something and that thing gets cited and people look at it and read it and it gets used as actual peer-reviewed research in places. And that just would have been unheard of in the past. So,
Yeah, well, to me, that's always been one of the highlights of the Association of Lunar and Planetary Observers, because we are a group of amateurs, but we are doing professional work. I
right,
mean, our observations have been used for many space probes to the moon and planets as well. So amateur definitely has a role in professional studies. And like you, we can look at whatever we want whenever we want. You know, we don't.
right.
We're not dependent on telescope time. That's the key. And what you're doing, I mean, I applaud you. I really do, because it takes initiative. It takes a passion, and you definitely have that for doing this. I mean, it's really amazing. I wonder if I were to look at your bookcase, what are some of the books that you've worn out on
Oh
astronomy?
boy. Well, I'd say one of the more notable ones, The Little Superfluous, and I can't recall the exact title being all the way over in Michigan, but
Mm.
there was this one that really caught my mind. I was in the library at some point, and I spotted this big, thick book, one of those ones that you can knock someone out with.
Hmm.
I think it was called NASA Atlas of the Solar System.
Okay.
It was this big picture book that had all of the highest resolution pictures we'd had of the solar system, of all sorts of moons and planets and comets and all sorts of things like that, with descriptions of what sort of content was really attracting the scientist's eye at the time. You know, looking at Io and discussing the abject lack of craters on the surface, seeing that, well, the surface must be pretty darn young for us to not have seen even one asteroid hit. I mean, even Earth's got a couple.
Yeah.
And something that really caught my eye about that one, that was a real inspiration, uh, was you're panning through all these things. There's Mars, there's Jupiter, but the Mercury section, half of Mercury's blanked out. It's just a gray smudge or a black smudge in some printings, probably. And that just blew my mind that there is a planet that we haven't seen. And this comes from way back, so
Right. Right.
Pluto was just well, it was 3 pixels seen by Hubble in 2006 or so, and that also really captures the mind that,
There's so much more to see.
yeah, stuff that you really feel like is the sort of fundamental stuff that in the future you'd just consider for granted, but if you'd gone back even 50 years ago, you probably wouldn't be seeing half these pictures in the first place. And it just reminded me that the process of all this scientific discovery going on isn't something that's already happened. It's something that's still happening right now, even at the most basic things of what does the dark half of Mercury look like. That wasn't solved until 2012. And
Good point.
there's other stuff that we still haven't figured out. I mean, we have no idea what Eris looks like. Eris is bigger than Pluto.
Hmm.
And so I try to do my best to pave the way from the inspirations of things like that book there, uh,
Yeah.
to try and cover in the other half of the globe.
Now, do you have a personal telescope that you pull out and use, or
I did at some point.
okay,
I had, and I still do have. I have a 6-inch telescope.
okay,
I think it was the Orion Star Blaster.
hmm,
And I did observe quite a bit with it. I remember seeing Comet Neowise back in 2020 with it, pointing that thing at it. Uh, I've seen a few novae and such that
okay,
get bright enough. Unfortunately, I haven't been using it much with the increasing LA light pollution.
yeah, I hear you.
It's I pull it out every year and it gets one magnitude fainter.
Well, we have smoke right here now too. So
Oh yeah, not much use this time
yeah,
of
yeah,
year.
we're recording this in the middle of the LA fires, so it's been a nasty time in this area.
Maybe there's a an extenuating variable I've forgotten to consider over the last few years when I take it out.
There you go. So, wow. Sam, this has been amazing. Is there anything you'd like to share with our audience?
Well, I suppose I would say, if you plan on trying to look at the universe yourself, it doesn't have to just be with your telescope. There's plenty of amazing data out there that is equally yours. I mean, nobody's looked at it. Nobody's seen the comet in it. And if you took the picture yourself, it might as well be the same as a picture that nobody's ever seen before that you can be the first to look at and go, hey, look, there's a comet in it.
That's right.
I think that's worth quite a bit as well. And you can do that right now. There's nothing stopping you aside from an urge to look for it and find something that you haven't seen before and that nobody's seen before.
That's a good point.
All you have to do is I didn't start out knowing anything. All you have to do is just ask stupid questions around and find someone who's willing to answer them. And most importantly, make sure to share your data with the Minor Planet Center.
Good advice. I'm sure they like that. And you should have started at 7. You really should have. Think where you
yeah,
today.
I don't know what I was thinking.
Wow. Sam, please let me know. You said you're going to be publishing some papers.
Yeah.
Please let me know when you do, and I will promote them on this podcast. I'd really be interested in seeing them.
Right.
Okay.
I've got one that's not currently in the field of planetary science, and I hope it isn't in the field of planetary science for a while. No. Me and a fellow amateur who does some imaging in the north found a weirdly compact H2 region that's just a few arc seconds across in the middle of nowhere. It's nowhere near any sort of known nebulae, and we're currently looking into what the deal with that is. I don't know if you've seen the news about that O3 arc next to the Andromeda galaxy, but it's sort of.
Yeah, I think I glanced over that. I never really.
Oh yeah, it was sort of hailed as a big amateur discovery at the time. That it was so strange that there could just be this big arc of.
And that's you. That discovery was you.
Oh no, I can't claim credit for that one. Okay. But we got a tiny little region over there that we're trying to figure out what the deal is with it.
Cool.
I go all sorts of all over the place. Planetary science is just my bread and butter.
There you go. All right, Sam. Well, I want to thank you for coming on the podcast today.
Thanks for having me. I appreciated it.
All right. Well, that'll do it for this episode of the Observer's Notebook Podcast. I again want to thank Sam Deen for coming on the podcast today. Hey, what were you doing at 9 years old? We upload a new episode of the Observer's Notebook on the 1st and 15th of every month. You can subscribe to us on iTunes. If you do, please give us a rating and a review. I'd really appreciate it. You can also listen to us on Apple Radio, iHeartRadio, SoundCloud, Spreaker, Google Play, Stitcher, Amazon Echo, Spotify, and also on the ALPO YouTube channel. You can help support the podcast by donating to it via Patreon, where you can give up to $35 a month, and you'll receive 1 year's membership to the Alpo and producer credits on the podcast. With that, I want to thank the producer of this podcast, Steve Siedentop and Michael Moyer, for their generous support. The link for Patreon as well as the link for the ALPO is in the show notes. If you'd like to get a hold of me, my email address is cometman@cometman.net. Until next time, I hope you always have clear and steady skies. Thanks for listening.